Quadratic function applications. This one is involving numbers. The sum of two numbers is 10. Find the two numbers such that their product is as large as it can be, so that its product is maximized, or we could also say optimized. You'll see those words. And what is their maximum product? We're supposed to solve it by hand and with the calculator. So first we have to set it up in either case. X is one of the numbers, Y is the other number, P is the product of the numbers. You don't have to call it P, but that's a nice letter for product. So P is the product of the numbers, so P equals X times Y. That's called the optimizing equation. Now, we also have a constraint equation here because x plus y is constrained to be 10. That's what ties y to x, so we can end up solving it. So our strategy is going to be solve for y in the constraint equation and substitute into the optimizing equation, so p is a function of x only, not x and y, because we don't know how to handle a function of two variables in this class. So we're going to solve for y in the constraint equation. Here's the constraint equation. Subtract x from both sides. That moves it over to the right side, negative x plus 10. So there's the y solved for. Now take the product equation, the optimizing equation, x times y, but y is negative x plus 10, so that substitutes right in, right there, negative x plus 10. Then multiply it out, negative x squared plus 10x. So that is your function of one variable, and we recognize that as a parabola opening down, this kind of shape. And we also realize p of x is a parabola which opens downward because of the negative, so its maximum value occurs at the vertex of the parabola, right up here. So that's what we're going to find. We're going to find the vertex. So doing it by hand, the x-coordinate of the vertex follows the vertex formula, and we have right here that b is 10, so b is 10, and a is negative 1 right there, negative 1, so that divides to be 5. Okay, then we plug it into p's formula, which is negative x squared plus 10x. Plug that in, work it out, comes out to be 25. So the vertex point is 525, meaning that the maximum product of the two numbers is 25, achieved when x is 5. But we also have to find the other number. So y is the other number, and it's negative x plus 10. So y equals negative x plus 10, which also coincidentally equals 5. So the two numbers that we're looking for are 5 and 5, and the maximum product is 25. Doing it with the calculator, you take your product function of one variable, so you have to do that work to get this far. Then you plug it in to the calculator. You work some kind of window in order to make it look, make you be able to see the vertex up here. You can see it's a parabola opening down like it was supposed to be. Then you use second calc max, second calc maximum. Second calc max gives you this point right here, and as you can see that it's 5. This number, remember, it's a numerical method, approximation method is being used to find that point, but we know that it's 5. It's rounding off to 5, and the p is going to be 25 right there. It says y, but that's not the same y. That's only because we're working in the calculator and they call all the vertical axis y. Remember, that's p. The product is on the vertical axis the way this is being graphed, so the p is 25. Then we still have to find the other number, so we get the y by y equals negative x plus 10. That's negative 5 plus 10, which is 5. So the two numbers are 5 and 5, and the maximum product is 25. So that's the calculator way to do the problem. You can always do it by hand, check it with the calculator, or vice versa.